Okay, so first off, let me start this video by saying congratulations. If you're watching this and you're in order in class, this is the last video for the general coursework. So that means that you've come through rigid and flexible hose lines, all the FARs, all the everyday type of boring stuff that we've got to get through to be competent mechanics. So today we're going to talk about taxiing aircraft. Or taxiing running aircraft on the ground. But before we get going, we need to cover fire extinguishers, because fire is a thing that we always need to be conscious of when operating aircraft. That's both in the air and on the ground. And so like in the Army, whenever we would crank an aircraft, we would always have a guy running fire guard with a rollaway fire extinguisher. In case something were to happen, they would be able to run up there and put it on. All the aircraft have had fire extinguishers inside of the helicopter, so that way if someone were to catch on fire, you could put the people out. It wasn't enough to put aircraft fire out, but it was enough to like save somebody's life, or at least keep them from getting seriously burned. Now, most aircraft, commercial aircraft, are going to have they'll have internal fire suppression systems that we'll get into whenever we get to power plant and airframe. And we're going to talk about these a little bit more. Most general aviation aircraft, it's hit or miss. Some of them have them, some of them don't. There's not necessarily a hard and fast requirement to carry them, but it's always a good practice to have them on board, just like a boat or anything else, because you never know what could potentially happen. Now, so let's talk about the different types of fire extinguishers first off. So in order to understand types of fire extinguishers, we need to understand types of fires. There's three types: A, B, and C fires. So A fires, I'm gonna read you the definition, is involves ordinary combustible materials such as wood, cloth, paper, upholstered materials, and so forth. The fire that you're probably gonna be the most familiar with is gonna be a Class A fire. Your bonfire, if you sack a bunch of pallets and burn it on the weekend with your buddies, that's gonna be a Class A fire. A Class B fire involves flammable petroleum products or other flammable or combustible liquids, greases, solvents, paints, and so forth. So whenever you're a kid and your mom's cooking on the stovetop and all of a sudden like the grease catches on fire, and then she puts baking soda on top of it to snuff it out, that's a Class B fire, a grease fire. Now we'll have those in aviation pretty easily as well, because what will end up happening is that you'll end up having petroleum products catch on fire. They're the most common, but we also deal with a lot of chemicals, and we also deal with a lot of chemicals that are in storage. Sometimes those chemicals can spontaneously combust, or you mix two of them together, you might get a fire. All of those are potential Class B fires, and you need to know how to go about putting them out. Now, Class C fires involve energized electrical wiring and equipment. So Class C fires are probably some of the most dangerous, because what ends up happening there is you have an electrical fire. Now, this is also, and I've seen these, and we've talked about them before, like electrical fires on board an aircraft. Now, whenever you have an electrical fire like that, you can't just go and just spray water on it like you would like a Class A fire, because that could cause any number of other problems. You have to have the right extinguisher to put them out. So what is the right extinguisher? Let's go through the different types of fire extinguishers. So water extinguishers are best used for Class A fires. They're pretty simple. Like you've had to put out a fire before, I'm sure. Even if it's a campfire, you take your canteen, throw water on it. That's all a water fire extinguisher is. We'll put a picture up of what a water fire extinguisher looks like, so that way you're familiar with them. But essentially, you're just going to take that fire extinguisher, aim it at the seat of the fire. The seat being if you look at like a campfire, kind of fire always burns up and out. The seat is at the very bottom where the base of the fire is, usually where it's the hottest. And you're gonna shoot that water on there. And what that water does is two things. One, it's gonna completely throw the balance of oxygen off inside of the chemical reaction that's creating the fire, and it's going to deprive it there. But number two, it's also going to instantly turn to steam. It's going to remove heat. Now, a lot of people think fire is some sort of like weird witchcraft, but really it's just a big chemical reaction that's happening. And in order for that chemical reaction to continue to happen, it has to have heat. Water, all that water really does is it turns to steam, and it removes the heat from the seat of the fire. And as it pulls that heat away, the chemical reaction starts to get less and less and less, pretty drastically so. And so a lot of times, whenever you're spraying water on a fire, what you're really doing is just simply removing the heat from the situation. As the heat goes down, the chemical reaction slows down and eventually goes out. And that's your water type fire extinguisher for your Class A fires. Okay, so water-tight fire extinguishers are not recommended on Class B fires. Remember, Class B fires involve flammable petroleum products or other flammable or combustible liquids. So go back to the example of your mom with a grease fire, right? If she went and took the little sprayer from the kitchen and shot that grease fire, all it's really going to do is going to hit that grease fire. And it might put it out a little bit, but what's really going to happen is going to push that grease out of the pan, and it's going to increase the surface area of that grease and therefore increase the fire, because the fire has to have oxygen to combust. So it's burning the grease, but it's contained to just what's on the surface because there's no oxygen below the surface of the grease. But if you were to spread it out, you increase the size of the fire and you increase the likelihood that it's going to spread to other things as well. So don't use water, because that's the water and oil don't get along together, and you'll end up just spreading that fire even broader and to other things that you don't want it to be on. So carbon dioxide extinguishers are used for Class A, B, and C fires. Then they use it by depriving oxygen. So you've seen these before, I'm sure. If you ever take a fire extinguisher and you pull a trigger and it shoots out this white powdery substance, that's a CO2 fire extinguisher. What that's doing is it's basically just like putting baking soda on top of the grease fire. It's just covering it up, and it's preventing the oxygen from entering the fire to help put it out. Now, they don't recommend using these on aircraft because the dust gets all in everything. And so if you have like a localized fire and you shoot it with a Class B fire extinguisher, well, then you put out the fire, but you might create about a dozen other problems. Now, so it says never use CO2 on Class D fires. D fires are they involve flammable metals. It's a fourth type of fire that we didn't talk about, but Class D fires, the most common one you're going to see is magnesium burning. Most of the time, if you have magnesium burning, you have a Class D fire that's actually that's ongoing, just don't mess with it, because you don't have anything that's actually going to put it out, and you're probably just going to end up making situations worse, if not get yourself in trouble. Okay, so so far we've got water, we've got CO2. Let's talk about halon, or halogenated hydrocarbon extinguishers, are most effective on B and C fires. So your different types of fires, your paper burning, your regular combustible materials, your petroleum products, chemical fires, and then you have electrical fires down there, and then you have metal, which we're not really going to mess with. But like halon works really good on B and C fires. Now halon is actually pretty common in the industry, but and you can see them in fire extinguishers that, generally speaking, that you'll have more CO2 or Special K, or one of those types of materials that just basically blanket the fire and remove the oxygen from it. Halon, on the other hand, can be really, really corrosive, and it can be really, really bad for you. However, it is extremely effective at putting out a fire. So if you think about like your tanks, like so M1 Bradleys and or your M1 Abrams and your Bradleys and things like that, they have a halon system on there. It's like a fire extinguisher with like little distributors all throughout, kind of like a drip irrigation system you would have in your yard. And you pull that handle, and it shoots that halon into the tank or whatever. You'll also see these on some aircraft as well. Now, that's really good for putting out the fire, but it's highly corrosive afterwards. So basically, whatever the halon touches is basically going to have to come out of that aircraft, because you'll basically never get the corrosion to stop. And two, it's extremely corrosive for people. It's not good for you whatsoever. So you generally speaking, want to stay away from halon if you possibly can. Only use it whenever you absolutely have to. Let's see, halogenated hydrocarbon, commonly called freon by the industry, are numbered according to the formulas with halon numbers. So you'll have these different types of halon numbers, like 104, 111, 101. If you want to know all about those, go look at it in the 8083. There's a lot to know about halon and about the different types and all the details that go into fire extinguishers. For our purposes today, we don't really need to know that. We just need to know that, hey, there are different types of fire extinguishers are used for different types of fires, and then how to use them. So dry powder fire extinguishers, another type. So I mentioned like a Special K. There's a bunch of different types, but they're all dry powders. While effective Class B and C fires are best used for D fires. So like if you have like a magnesium transmission or structure of some variety that's on fire, you're going to use a dry powder fire extinguisher. The method of operation of dry powder fire extinguishers varies from gas cartridge charges stored with pressure within the container that forces powder charge out of the container to scooping pails or buckets of the powder in large containers or barrels to toss on the fire. Now, I've never seen scooped buckets, but whatever. But squibs and like fire extinguishers that discharge and then shoot an area full of this powder, I've seen that, and that's something that we will cover in a lot greater detail as the course progresses on. Okay, let's talk about the inspection of fire extinguishers, something that you will do. So first off, there's a couple things we're going to look for anytime you're doing a fire extinguisher inspection. First off, whatever document is driving you to inspect that fire extinguisher, be it an AMM, some sort of local procedure or whatever, most likely it's going to have the best information for what that fire extinguisher inspection entails. And so follow that. If you're doing a generalized kind of fire extinguisher inspection, these are the things that you're going to be looking for. First, the proper location of appropriate extinguisher. That's two things: is in the right spot and is it the right type. So that document, whatever is driving you to inspect that fire extinguisher, will basically tell you those two things. So make sure that they're there, and also make sure it's secure. A lot of times you'll have a band clamp that just like locks that fire extinguisher in place. Over time, they can become corroded, they can become weak, and so you want to make sure that you can actually secure that fire extinguisher, because the fire extinguisher, if you're in flight and you roll and it falls out of that carrier, it can become a more of a hazard than a help. So you want to make sure that it's secure. Safety seals are unbroken, so you want to make sure that your fire extinguisher has the seals that's been inspected, and that it is in date, and it's not been broken or tampered with or anything else, because legally it wouldn't be valid if it's broken. And on top of that, how do you know that it's actually good if the safety seal is broken? All right. All external dust and dirt and dust removed. Keep in mind that fire extinguishers are generally ferrous metals. Dirt and dust can help speed along corrosion. It could eventually corrode, pit, cause a hole, and it'll leak and won't be any good anymore. Gauge or indicator is an operable range. So there's always going to be a gauge on it, and they'll have a green band that says, hey, look, the pressure is good right here. You want to check and make sure that that's good. The proper weight. Once again, the gauge will probably will take the place of that, but there's that. There's no nozzle obstruction, so that way you don't have a dirt dauber that's gone in there and sealed it up, so that way when you pull the trigger, nothing happens. It's because the nozzle is obstructed. And no obvious damage, which goes without saying. If it's like got a big ding in it or something like that, then you probably want to get it replaced. Okay, so those are fire extinguishers. Now, so generally speaking, this is the procedure you're going to use for a fire extinguisher. You're going to grab it. So I'm just going to read this right off the 8083, and then we'll kind of talk about it. When using a fire extinguisher, use the correct type used for the fire. So you're going to look at it and say, like, I have a bunch of paper on fire. Here's a Class A fire. We're going to grab the fire extinguisher, and then we're going to say, hey, look, this is a water fire extinguisher, so it's good for Class A fires. Off we're going to go. Most of the time, the fire extinguisher that's going to be there, that's going to be handy for you to grab, has already been optimized for whatever could potentially go on, catch on fire there. If you have the potential for some of these more exotic types of fires, most likely you're going to end up having fire extinguishers that are pre-positioned in that area. Either way, you're the one that's putting out the fire, so it's going to be on you to make sure that you have the right fire extinguisher for the right fire. Okay, most extinguishers have a pin to pull that allows the handle to activate the agent. So what ends up happening is that you'll have a valve. So if you imagine like a tank, and you have like a little valve that goes up and down that releases the agent. There's going to be a handle in there that is just a lever that you squeeze down, and that lifts the pin up and lets the agent leave the fire extinguisher. Now, when that happens, or to prevent that from happening, they usually have a metal pin that goes through there. So when you're going to take the fire extinguisher off the wall, you're going to pull the pin, which will also break the safety seals, and then it's a live grenade at that point. You can do whatever you need to with it. All right, stand back 8 feet. Now, the reason why you want to do that is for two reasons. One, you want to make sure that you get the right range of the right spray pattern from the extinguisher, and number two is that, like, when you're shooting a fire that's under pressure, with a fire extinguisher that's under pressure, you have a good potential to spread that fire out. So, like, if you think about your grease fire, right? If you go up to it and you're like, I'm gonna hit this thing with some water, and you shoot it full of water and it throws grease everywhere, that fire could end up on you or on something else. So you want to just kind of stand back to try to alleviate some of the pressure, get the right spray pattern, and put it down. And that'll keep you the safest. Okay, aim at the base of the fire. So remember the seat of the fire. You want to aim at that and shoot there. Squeeze the lever and sweep side to side until the fire is extinguished. So you're aiming at the base of the fire. You're gonna go back and forth and like try to cover as much area on that seat to help put that fire out. So now that we understand fire extinguishers and how to put out fires, let's move on to taxiing airplanes. Okay, so we're going to crank and taxi an aircraft. So what does that look like? All right, so before starting an aircraft engine, you need to position the aircraft to head into the prevailing wind to ensure there's adequate airflow over the engine for cooling purposes. So basically you want to think about where the wind's coming from and then point the nose of the aircraft in that way. Reason being is that you want as much airflow coming over the top of that engine as you possibly can to help reduce the cylinder temperature. Then you make sure there's no property damage or personal injury occurs from the propeller blast or the jet exhaust. So you want to look in front of the aircraft and around where the prop's going to be or where the engine intake is, and make sure that there's nothing that's going to get sucked up into the engine. But then you also want to look on the backside and think about like what's going to happen whenever all of that air goes backwards, and that, you know, is there going to be anything that gets damaged there? All right. If external electrical power is used for starting, ensure that it can be removed safely and is sufficient for the total starting sequence. So there's a lot of times you'll end up having aircraft that'll have external starting batteries or start carts that are plugged up to it, or it may be plugged into an external power source that goes to, say, like a wall outlet or whatever. You want to make sure that apparatus, whatever you're using, is sufficient for starting the aircraft. But you also want to make sure that, like, once the aircraft started, you're not going to pose a hazard to yourself or anybody else by disconnecting it. Then during any and all starting procedures, a fire guard equipped with a suitable fire extinguisher shall be stationed in the appropriate place. Remember I was telling you about the Army, we always had a fire guard on there. You want to do that just as a general procedure, because you never know, especially after maintenance has been done, if there could be like something may not have been done correctly, or if there might have been some fuel left over from some sort of engine cleaning or something like that, that a fire could start. Now, what happens if a fire starts? So as the person who is cranking the engine, you want to just continue to crank. And the reason being is that, like, as that air like starts coming into the cylinders, it will snuff the fire out. If that doesn't work, then you want to stop doing what you're doing and abandon the aircraft and let the fire guard approach the aircraft and put it out like that. So that's the way you're going to handle engine fires. If the aircraft is a turbine engine powered, the area in front of the jet inlet must be kept clear of personnel, property, and or FOD. Now, this is a big one for like turbofan engines. So let's say you're cranking a 737 or 777 or something like that. That engine inlet is extremely powerful. So it's going to suck things in. Like you'll see guys that are standing too close to it, their clothes will start to flap in it as that turbine starts to spin. My favorite thing to point out with especially one of the JT9s is that if you watch one of those big turbine engines run in the rain, they will form a vortex at the very base of it. It will spin and create like this water spout, like kind of like a little tornado. It'll come up and make a 90-degree turn as it follows the airflow, and it is the coolest thing to watch. But that just goes to show you how much power those engines actually have. And it's not too different from a prop too. If you have a turboprop that's spinning and it's not, you know, feathered, like it could do the same thing to you. You could start sucking things towards this big spinning blade. So you don't want to have anything anywhere close to it that could damage the aircraft or get somebody hurt or damage something. Usually all three will happen if something goes haywire. All right, these before starting procedures apply to all aircraft and power plant. These are just good practices, just in general. Think through what you're about to do before you do it. And follow the manufacturer's checklist for start procedures and shutdown procedures. So every aircraft is different. Every single one. Even some of the same models are different based on the configuration that they're in or what STCs have been done to them. So whatever that aircraft's checklist is what you want to follow. You don't want to just do it from memory or do your own thing or it's just like this other one or anything like that. Find the checklist that is appropriate to that aircraft and then follow it. Don't make the mistake of just kind of just doing things all willy-nilly and then get yourself hurt, get you something broke, or yourself in trouble. All right, so let's go talk about some general, this is a kind of a general overview of how reciprocating engines get started. Now, every single aircraft is going to be a little bit different, just because you're talking about a span of time from the 1940s till today that these reciprocating engines have been employed in use. And because of that, there's all different types of engines, there are all different types of aircraft, there's all different types of configurations, technology differences, and so there's always going to be some variance, but generally speaking, they will follow these procedures. First thing, you're going to turn the fuel pump on. You're going to supply electrically powered fuel all the way up to the engine, so that way it's ready to grab that fuel and start working as soon as you hit the starter. Then you're going to place the mixture control to the position recommended for the engine and carburetor combination being started. So most of the time that's going to be full rich on the mixture. If you're in like a regular reciprocating engine, it's just going to take the little red knob and go all the way forward. But it could be different depending on what engine that you're working on. So always follow the checklist. Then you're going to open the throttle to a position that provides 1,000 to 1,200 RPM. So on my airplane, you're going to crank it about 3 times. That gives you about 3/4 of an inch of throttle. And when it cranks, it always wants to go up high, so you end up having to kind of throttle back to try to get to that 1,000 RPM range. Leave the preheat or alternate air carburetor control in the cold position to prevent damage to the fire in case of a backfire. So you're going to take your preheat or alternate or carb air control and make sure that it's closed and make sure it's off, in my airplane at least. Move the primer switch to on and intermittently press and prime in on the ignition switch during the starting cycle. So priming aircraft is going to be different on every aircraft. On the Piper Cherokee that we're going to crank, it's just going to be, there's a primer that comes out and goes closed 3 times. And you can feel it pull the fuel whenever it pulls back. You can hear it. It'll go and it'll stop, and then you press it forward. No, that's just priming that engine and getting ready to start. Okay. Energize the starter, and after the propeller has made at least 2 complete revolutions, turn the ignition switch on. Now, this is kind of dated. Most aircraft don't work this way. They could work that way. But clear! What you will typically do is you'll either have a magneto switch that says left, right, and both. You're either going to turn it to both and then press the start switch, and then that will start it, or you're going to well, as soon as you hit both, it'll have another notch or a momentary switch where it'll say start, and then once it starts, you can let go and it'll go back to both, and you're good to go. It just depends on how the aircraft is configured, and which is why the checklist is so important, because the checklist will be optimized to the aircraft that you're starting. All right. After your engine is operating smoothly, move the mixture control to the full rich position if started in the idle cutoff position. So essentially, if like you just had to put it in the idle cutoff and it's just starting, it's going to want to like kind of like, so go ahead and go full rich if you didn't already do that per the checklist. Then probably the most important thing to do is watch the engine gauges. So like some examples could be your fuel gauge, your fuel flow gauge, your suction gauge, your engine temp, your oil pressure. All of these things are indicators of how that engine is doing. If you see one that's not in the green, if it's not in the ideal situation, something's not right and you need to take action. It could be, hey, look, we're just going to monitor that. Or it could be hey, look, we need to shut this thing off. If you have like no engine like oil pressure and the temperature goes up, you have like not enough oil in that system for some reason, either a leak or it was never put in there or whatever the situation is. You need to shut it off or else you'll damage the engine. If you have like excessive pressure, then that means there may be too much oil, which could cause any number of problems. So just go ahead and shut it off. Sometimes you'll get things where it's just like the suction gauge is not there for whatever reason, and you're going to watch it. Like my plane, like the battery always gets drawn down and the amp meter is always pegged out whenever it starts. But then after about 10 or 15 minutes, it recharges the battery and the amp meter comes back into the range. And some engines have personalities, just like people. Like they'll have these little quirks that you need to pay attention to, and you get to know them as you go. But you also have to kind of develop the professional expertise to know what is serious and needs to get shut down and what is something that you can just monitor. And that just comes from experience. let's go through the procedures. Like if we were going to hand crank an engine, so what would that look like? All right, so the person who is turning the propeller calls fuel on, switch off, throttle close, brakes on. So the guy, there's going to be two people. One person that's sitting in, like operating the controls, the other person reaching up to actually hand crank that engine. And this is very common on older airplanes. Before starters were put on, you had to hand prop an engine. Like, so you'll still see, you go to stall competitions, and you'll see like Piper Cubs being like, hand propped this way. But the first person that sit in the engine is going to like make eye contact with the person that's going to touch the prop, and that person is going to say, "Hey, is the fuel on?" And they're going to say, "Yes." And the switch off? Yep, it's off, so it's safe to touch. And the throttle is closed, so even if I do crank it, it's not going to get any gas to get going, and the brakes are on. So in the worst case scenario, if we've done everything else wrong, the brakes are I'm standing on them. The airplane can't run me over. All right. The switch and throttle must not be touched again till the person swinging the prop calls contact. All right, so the guy who's going to actually grab and push the prop down is going to reach up there, grab it and say contact. The operator then repeats contact and then turns on the switch, and then never turn on the switch and then call contact. So what's going to end up happening is that, like, once you have your pre-checks done, the guy who's going to actually crank the engine steps up and says like contact. The operator, the pilot, is going to say like contact and then turn the switch on. All right. While touching the propeller, always assume the ignition's on. So the guy that's touching it is always just assuming that like he's just one little jerk away from cranking that engine up. Be sure the ground is firm. So usually people are going to have to grab the thing and they're really going to have to push down on that prop. What you don't want to do is slip and go into the prop as it starts to crank, because that could end up killing you. The worst case scenario, it could like send you to the hospital, or best case scenario, send you to the hospital. So you don't want to do it on any kind of like slick, muddy ground or anything like that where you could slip. You want to be able to have like a good, nice, firm feet, and you want to be able to grab it and step away, so that way whenever you crank that thing, you're well away from the propeller, so as it goes. And you'll have to do it 2 or 3 times. You'll see guys sit there and just go over and over and keep on hand cranking it, just like you would having to pull the starter cord on like a lawnmower or a boat motor. It's the same concept. You're just using a prop rather than a rope. And it could take a minute. And so you don't want to get tired and get lazy and get sloppy and accidentally like cause yourself to get hurt. Okay, in swinging the prop, always move the blade downward, pushing the palms of the hands. Don't grip the blade with the fingers curled over the edge, since kickback may break them or draw your body in the blade path. Okay, so when you grab the blade, so here's the blade, you want to do it like this. You don't want to do it like this. The reason being is that if that thing goes and you got your hand full of it, you're going to get pulled down into the prop. If it kicks back, so a lot of times you'll see like as the cylinders will fire, sometimes the blade will move backwards. So if you get your hand out there, it could move you forward into it as well. So generally speaking, just push down on it and just your default mode is always just get away from the prop. Just get away from it, let it do its thing, because you can't control it once it's in motion. Okay. Avoid overpriming the engine before it's turned over by the starter. These can result in fires, scoured or scuffed cylinders, pistons, engine failures, and hydraulic lock. So like you don't want to overprime it. If you flood the engine, nothing good happens from that, so don't do it. All right, so let's talk about turbo prop engines, and we're going to go ahead and lump turbojet engines in it as well, and just kind of talk about the differences. So you're actually going to do this in class. You're going to crank and you're going to taxi the Lear. So the first thing you're going to do is, in general, you're going to follow the Lear's checklist. You're going to turn the boost pumps on. Make sure that the power lever is in the start position. So turbine engines are a little bit different than your reciprocating engines. So they have a start position for the fuel. You're going to place the starter switch to on. So you're putting power on the jet now. The ignition switch is going to come on, so the fuel is now turned on. You're going to monitor the engine lights for the exhaust temperature. And so as you're on the Lear, as you're hitting the ignition switch, you're going to start to spin that engine, and you're looking for like 11% NG to go, or MP, NG, yeah, to go. All right. So you're looking for 11% of that. So that's 11% of the total max RPM of that engine. So you're hearing it spin. As you turn the fuel on, you're going to hit the igniters. The igniters are going to fire, and when they fire, you're going to get a spike in exhaust gas temperature, EGT. You're going to see that go up. You don't want it to exceed certain numbers, and that's in the checklist. And whenever we go to do it, we'll have a whole class on how to do this. But I just want to get you familiar with the process. That you don't want it to go too high, because if it goes too high and you hot start the engine, that engine's no good anymore, and we have all kinds of other problems. But if you go too low, you'll have a hung start, and it just basically you're just eating up resources, and we have to like do it all over again. So you're looking for the right NG percentage. You turn the igniters on, and you throw the gas into it. You hear boom, boom, and it'll start to go, and you'll see that RPM start to climb. Once it gets to a certain point, we can disengage the starter, and the engine is now running at that point. And it'll sit there and go, it'll charge the batteries, it'll do everything it's supposed to do. But you just have to go through that procedure correctly to make sure that it's done in the right way, or else it'll damage things. Okay, once it's done, we're going to always monitor the engine oil pressure, or the engine temperature, all of the engine data we're watching to make sure that we don't have a fire, we don't have any sort of like engine problems or anything else like that. Then we're going to just disconnect the ground power if we were using it, which we won't in our case because we'll crank off batteries. And then we will also like wave off the fire guard, and he'll go on his merry way. All right. Now, turbo fan engines, so like your 777s, 37s and stuff, it's actually, you would think it would be a lot more involved. It's actually pretty easy. There's going to be a checklist to follow in the AMM or in the flight checklist, if depending on what you're using. But essentially, what you're going to do is you're going to have ground power on, bat 1, bat 2 comes on, and then there's going to be a knob up there. You turn it to start, and the engine does all this stuff for you. And that makes sure that the engine is cranked correctly through the full authority digital engine control. FADEC will do it for you. Same thing with the APU. Now, most places to do this, you have to be engine run qualified, and you have to have like an APU class to run the APU. The APU is actually not really that big of a deal. The auxiliary power unit in the back of the plane that supplies like hydraulic power and electrical power, and sometimes air, depending on the make and model, to the rest of the jet. So you'll do that. That power will come on, and you'll use APU power on a pretty regular basis. Engine run is also not really that big of a deal, but you have to have the right certs to be able to do that legally. Most places, some places they're not that refined. You just follow the AMM, and it'll tell you what to do and what not to do and what to look for. A lot of the times, whenever you're running engines, you're primarily there to watch and make sure nothing is happening, and to stand by the fire handles in case like an engine fire were to crank out. But as far as the actual operation of the engine, the computer will do most of that for you. All right, so as we crank the aircraft and we taxi off, there's a couple of rules of the road that we want to make sure that we stay on top of. First off, stay on the taxi line if you're on taxiway or in an area. The best way to do that is look down the taxiway, and the yellow taxi line should go in between your feet. So you should imagine yourself like sitting on top of the taxi line everywhere you go. And so as it turns, you turn with it, and you keep it in between your feet. That will keep the aircraft centered on the taxiway. You also want to pay attention to the where you're at on the airport, and you're going to do that through paying attention to the lines that you drive over the top of. There's a movement line or a non-movement line that is a solid yellow line with a dash line on the other side of it. If you're on the side of the dash line, you want to call the tower and tell them, hey, look, I need to go from point A to point B, wherever you're at. And then they will tell you, hey, look, like you can go and do that thing. If you're on the side of the solid line going to the dash line, you don't have to worry about that as much, even though you should be in constant communication with the tower, so that way they know, ground control knows like what's going on in there. We'll get to radio communications here in a second, but let's talk about the three primary methods of communicating with a moving aircraft. First off is hand signals. Okay, so as we pull up to a FBO or some area, A lot of times you're going to have a flagman. The flagman will get your attention, and then he'll point to a certain area, and he'll point to this area that you look at, and then there will be another guy that's standing there like Keith is right now in a yellow vest or some sort of high-vis vest to help move you around, to give you those right signals. Now, this is where we don't have radio communications. You're not going to use a light gun. You're just going to use hand signals. Now, this actually gets used a lot in aviation, and so we need to be well versed with them. So Keith is out there. He's going to give us a couple of different hand signals. Okay, go stop. Okay, come ahead. Yep. Emergency stop. Okay. Cut engines. Off. Okay. Start engines. Okay. Pull chocks. Okay. Insert chocks. Slow down. Okay. All clear.
What is it?
It says all clear.
All clear?
Yeah. Okay. I say left turn.
That's going to be right from you.
That's fine.
All right.
Okay. Right turn. Now that we've covered hand signals, let's talk about like light guns. Now, a light gun is an old school way of communicating with aircraft before there were radios. Essentially, like back in the day, you used to fly over things, and as you approached an airport, you would flash your landing light to let the tower know, hey, look, you're coming in to land. They would take the light gun, aim it at your plane, and then give you a signal. Now, those signals can be broken down into a couple of different colors. So a flashing green light, if you were on the ground, and we're not going to cover the ones that are in the air, because in theory you're mechanics and you're not pilots, so you shouldn't be flying it. But on the ground, if you look up at the tower and they give you a flashing green light, it means that you're cleared to taxi. It means that, hey, look, we see you, what you're doing, there's nobody else around, off you go. All right. If you see a steady red light, it means stop what you're doing. That means that, like, there's probably an aircraft that's coming in, maybe you're about to cross the runway, something's going on, just stop. The flashing red light means that taxi clear of runway in use. A flashing white light means to go back where you started from. So if you get a flashing white light, just do a 180, go right back where you started. An alternating red and green light means use caution. I mean, that there's something going on that they want you to be wary of, but they can't communicate it over light gun signals. Now, you most likely won't ever have to really use light gun signals, especially in the era of cell phones. Worst case scenario, if you have a radio out in a plane, just call the tower. Like, you can get on ForeFlight, and all those numbers are listed. You can usually just Google them and just tell them, hey, look, I'm in 1653 Juliet. I'm at this place and I need help. And they're going to talk you through it. Worst case scenario, you can use a light gun. Now, I've used light guns in the air before. Whenever we had a radio go out in a plane, and we tried to do the light gun thing, and it worked, but it's just like, it's such a wonky form of communication that we eventually just picked up a cell phone and called. And so there's that. But you should be aware of that. That's a possibility for you on the ground. Now, most airplanes will have those light gun signals placarded inside the airplane, so you don't have to really worry about memorizing them. But you could be asked on the test or by the O&P examiner, or you may just be good for you to know to just whenever you're out operating. Okay, so now let's talk about radio signals or radio communication. So the tower will have typically two different channels or frequencies to communicate with. You'll have the actual tower that's talking to airplanes that are operating inside of that airspace, and you'll have ground control. Sometimes, like at our airport, it's the same guy that's monitoring the same frequency, but know that there's a ground frequency. You as the mechanic will almost always be concerned with what tower ground is, not necessarily the tower itself. So you're going to tune your radio into that frequency. When you key the mic, it always follows the same method or same pattern. It says, "Hey you, this is me." So you'll say like Texarkana ground, Cherokee 1653 Juliet at Texarkana College, ready to taxi. And they'll say like, "Oh, okay." Well, they say like, "Hey, look, I understand that I'm Texarkana ground, and I heard that there's this person who's always going to be the registration number, unless you're in, say like some special vehicle, which you generally won't be." But so like, for instance, like the airport has a truck you'll see driving around called Ops 1. So that they'll say like Tower Ops 1 or Ground Ops 1. So that's it. If you're in the Lear, you're going to be 123 Charlie Kilo, and that if you're in my plane, it's 1653 Juliet. If you're in the other Cherokee, that's 7131 Whiskey. So like whatever aircraft you're in, you're going to use that registration number as your call sign, and you'll say like, "Hey, look, hey ground, this is me," like, and then you're going to say where you are, because like it's a big airport. Like they could say, "Hey, look, like I'm ready to taxi," and they're like, "That's fascinating. Where are you at?" Because I can't clear you to go from point A to point B if I don't know where point A is at. I understand that you may want to go out to the active runway or across the runway or whatever else, but where are you at right now? Because that will tell me where you're going. So you always want to say like, "Hey you, this is me, and this is where I'm at." Those three things. If you have those three things, then the rest of the conversation can kind of be navigated, even if it's not in proper etiquette. But let's talk about the rest of the conversation. When you call them, they're going to call back and they'll say like 1653 Juliet, clear to taxi. Your response is always going to be to repeat whatever it is the tower told you, and then follow up with your call sign, so that way they understand that you were that their instructions to you was understood. So if they said like 1653 Juliet, Texarkana ground, cleared taxi, you're going to say like cleared taxi 1653 Juliet, and there you go. So it's "Hey you, this is me," to get it going and where I'm at. They're going to say like, "Here's your instructions," and you're going to say like, "Roger that," and follow up with your tail sign, or your tail number. And that's kind of the basics of radio communication. You'll have to tune it based on the checklist, and just through experience, you'll learn how to tune different radios, and that's it. And okay, so why is communicating on the airport so important? So, and once you've crossed the movement, non-movement line, you're into controlled airspace, and that controlled space is there to keep people safe. So there are multiple instances where planes have crossed the runway as another plane is coming to land, and that could potentially cause a catastrophic event. It could also just jack up all the different traffic. Let's say like if you taxi onto a runway, that runway is not clear to receive an aircraft. Well, if you have an aircraft that's stacked up, ready to come in and land, well, then they're going to have to like tell that guy to go around and then come back again. And the guy behind him, well, he's going to have to do the same thing and same thing. And then the bigger and busier the airport gets, the more like a bit of a big deal this becomes. In Texarkana, it's not as big of a deal. It's still like a big deal. It's still a safety of flight issue. But like if they have to tell somebody to go around, it's usually not that big of a deal, because there's nobody like standing in line waiting to land. You go to DFW on the other hand, just go up there one day and then turn on FlightAware and just look at the long line of traffic. You've just inconvenienced all of those people, and a lot of that those people that are flying on those planes have connections to be made. Those aircraft are slotted for certain times to land. You've messed all that stuff up. So this becomes like a really, really big deal that you do exactly as the tower tells you, because they are air traffic control. They're trying to control the traffic to keep it as safe and as efficient as possible. You as the mechanic don't want to be the one that's responsible for messing all of that up.